What is a coefficient of discharge? During a fire hydrant flow test, we can measure the velocity pressure of water. This is done using a pitot tube along the center line of the stream. The velocity pressure is related to the amount of water we are actually flowing out of the hydrant. Experiments and just our own observations will tell us that the cross-sectional area of the stream is not the same as the cross-sectional area of the opening that it's flowing through. The area of the stream will be smaller than that of the opening. For a 2.5-inch outlet on the side of a fire hydrant, the flow will become more restricted and smaller just beyond the edge of the opening. This is called the vena contracta effect. Why does this happen? The path that water takes to get through an opening provides some forces that are perpendicular to the flow of the water in order to bend around a corner. These forces make the water constrict as it goes through an opening. Why does this matter to us? If we take the velocity pressure at the center line of the stream and assume that the cross-sectional area of the water is the same as the opening, then we're going to overestimate the actual amount of water that's flowing. Overestimating in this case would be bad, it would be less conservative. So how do we account for this actual amount of water flowing, which is less than the theoretical maximum? Well, that's our coefficient of discharge. The coefficient of discharge is an adjustment that delivers the actual flow of water based on the type of opening that water is flowing through. A coefficient of discharge of 0.7 is telling us we are actually flowing 70% of the amount of water when compared to a theoretical perfect stream that has an area exactly matching the opening size. We'll cover the math in more detail and how to apply this coefficient in future videos. I'm Joe Meyer. This is Meyer Fire University.